Hi, I'm Avihai, and I'll present our work. That's not my question, learning to weigh unmatched terms in CQA vertical search. So, the first slide that Yoel stole from me, what is CQA? So CQA stands for Community Question Answering. These are websites like Yahoo Answers or Quora or Stack Overflow, where users ask questions and other users answer them. They are typically used by users when seeking advice or recommendation from another person, or they have an open-ended question. And here we can see an example of a page from Yahoo Answers. There is a question title, which is typically a short summary of the question, then the body of the question, which elaborates. And at the bottom, one or more answers by the other users in the community. In the web search traffic, about 10% of the queries have some question intent in them. They are typically longer questions with about 4 to 6 terms, and they often have a more complex structure. And for these types of queries, the CQA page may have just the right answer. So in our team, we developed a system that performs high precision vertical search over Yahoo Answers. And if the system believes it has a high quality result, it is shown, like you can see here on the example, on the top of the result page, on top of all the other search results. This is a description, a simple high-level description of the system. Given a query, in the bottom part of the diagram, it's the normal flow of a web search. But in the upper part of the diagram, it's our system. We first have some classifier that detects a question intent in the queries to decide if we need to handle this query or not. Then in the middle, this is the retrieval and ranking module, which is the focus of what I'm describing today. And finally, a post-retrieval filter that determines if the system could retrieve a high-quality result and it should be displayed at the top of the result page or not. So, focusing on the ranking, which of the two questions here seems more relevant to the query deadliest snakes? Traditional ranking models like BM25 or even modern learning to rank algorithms typically focus only on the matching terms between the query and the documents, like the terms deadliest snakes that we see here, that both questions match. But what about excessive terms that we can see in the second title? The terms in Russia seem to make the scope of the question narrower and likely less relevant to this query. And common algorithms do not account for it. And in this work, this is exactly what we try to do, to directly consider the importance of such excessive terms. And here's another example. Which of the two questions seems more relevant to the query famous African night? Both questions match 2 out of the 3 query terms. However, each of them is missing one term. The first one is missing the word famous, while the second one is missing the term night, which seems more important for this query, and thus the second title is likely less relevant to this query. And similarly to the excessive terms, we also try to directly consider the importance of such missing terms in the ranking. So we use the learning to rank framework, which I'll shortly describe. We start with the Yahoo Answers index of 54 million documents and an initial ranking function. Given a query, the ranking function retrieves and scores the documents and outputs a ranked list of documents. in our experiments, in our system, the top 100 documents. These documents are presented to users which can either skip or click these results, and we collect these clicks. For this work, we collected about 140,000 such examples. This information is then fed to a learning to rank algorithm. We used SVM rank, which in turn outputs an improved ranking function that hopefully can rank the actual clicked document at the top of the list. In a bit more detail, what the scoring function or the ranking function and the learning to rank algorithm actually see is a feature representation that describes how well the query and document match each other. So our baseline, or what we started off, was the state-of-the-art feature set that is derived only from the matching terms. And in this work, what we did is enrich this feature set with new features that are directly capturing the information about missing and excessive terms. And hopefully this enriched feature representation can allow the learning to rank algorithm and in turn the scoring function to do a better job in ranking. So for evaluation, we had a set of about 60,000 examples where we have the top 100 documents and we know which one is clicked. What we have here on the horizontal axis is the query length, the number of terms, and in the vertical axis, the MRR measure that shows how high the clicked result was ranked, and in general, higher is better. The blue plot is the baseline method. This was the state-of-the-art ranking using only the matching terms between the query and the document. The green line shows the results when adding to the matching terms only the missing terms. And we can see that except for queries of length 1, because there is no such thing as a missing term there, it's either hit or not. But for longer queries, we see across the board that it improves the results. Next is when adding to the matching terms only the excessive terms, which showed even further improvement. And finally, when combining both, we got the best results. So here is another example. For the query, deadliest snake, and the title or the question, which is the most poisonous snake? What can our model say about this query and document pair? So the term snake or snakes are a match. But what about the terms deadliest or poisonous? They seem like it's not a lexical match, but we know there is a semantic relation or relatedness between them. So can we apply some soft term matching method to utilize this? So the short answer is yes, and I don't have time to describe the details, but oops. So the purple line that you see here was the best results that I showed before using the missing and excessive terms, but when limiting ourselves to strict lexical matches. And the orange line is the ranking results using the soft matching method that we applied here. And obviously, it gives a huge improvement. So to summarize, we empirically found in this research that directly considering the unmatched terms can improve the ranking quality. We also found that we can use a word-to-vec based term matching method to improve the ranking quality even more. And you can find more details in our SIG-IR paper. Thank you.